Hi everyone! Lately, I've been on the coding grind for developing my text-based strategy game Cult Game, which you might know if you've followed me for a while. This is the game where you start your own cult, and I've been working as a solo developer on this project for quite some time, and I've been really enjoying it, but it's met quite a bit of isolation actually, so I decided to take this past December to show some of my work to other programmers by participating in the Advent of Code programming contest. For those of you who don't know what the Advent of Code programming contest is, it's a fun challenge where programmers compete to solve tough computer science problems faster than each other. There's quite a bit of collaboration and learning, so that's a lot of fun for me. And nice change of pace. I made it up to day 5 out of the 25 days, because it gets pretty hard. And you can see the work I did, and I'm going to put a link in the description for that. So hopefully you might enjoy that. So, I was surprised by the amount of people who viewed and downloaded my code, as well as the fact that someone cared enough to even submit a revision of the code that I made. And that was for the first time ever that's happened to me. Just some rando online just said, hey, I liked your code, here's my version of it. And that's a really cool experience, as I'm just used to working alone here in my house, right? So, this inspired me a bit, right? What if I took some of the code I used to make Cult Game, some of the string utility functions that I made during Advent of Code, and I released them to the public under my own library, right? How many people could it reach? Imagine how many people I could help. Maybe some code might end up in a new smart fridge that can play Elden Ring for God knows what. I don't know, but that'd be cool, right? So I would be indirectly improving the back end of Cult Game by working on this project and also getting some good feedback on my coding style. It's an attractive idea to me, so I started it up and I did it. Alright, so to begin, I had all of the string utility functions I made under a single class object I named stevensStringLib. Easy enough, right? If you wanted to use my library, you would construct the library object and start calling its functions wherever you would want. This would be all the code from my library written into a single .h file, and to install it into a project, you would simply copy the .h file and paste it into your project. And then you would go into the source code where you would want to use my library, and you would put a hash include stevensStringLib.h at the top of the source code file. I thought I was close to being done at this point, but I was wrong. So I created a post on Reddit's C++ subreddit, r/CPP, and I let the council of C++ wizards see what I had done. The result? Not the best feedback. For real though, lots of C++ programmers more advanced than me gave me a lot of feedback, and that was super valuable, so I was totally fine with it even being overly critical at times. One of these people even wrote a whole blog post about my library. Although there's a part of us that doesn't like all of this, criticism from so many different angles being pushed on us, because I don't know, maybe we weren't built to handle social media and hundreds of thousands of people potentially, saying things that we disagree with all at the same time. It's the only way we can get better, to have people look at our stuff and tell us, this is good, repeat this is bad, don't repeat this, right? I'm out of school right now, and I'm used to working alone, so these coding gods on the internet that I find on Stack Overflow or on these Reddit forums are one of my few ways to get new wisdom, so I gotta humble myself to their commandments. And I did, and I improved things quite a bit. Alright, so let's go through the 8 major points that people suggested that I ought to change about my project. Number 1, do not use a class, use a namespace. I recently spent a year and a half at a job where I learned a lot of my coding habits. We use the Cold Fusion language there, and in Cold Fusion it's normal to have lots of libraries that exist as class objects, which you call the methods of. I understand that this is normal for Java and lots of other languages too actually, but in C++, It's conventional for libraries to exist as namespaces instead of classes, as classes are considered more useful for keeping track of things that can be instantiated and associated with unique data that can be changed via class methods. Namespaces, on the other hand, are better if you just want to have a bunch of variables or functions that are loosely associated with each other with a naming convention. We're making a library, which in this case is just a bunch of functions. So in this case, using a namespace is best. Number 2, use pass by reference. In C++, we have the ability to choose if we would like to directly manipulate the variables that we pass into functions instead of making copies of them in the function call. This is called passing by reference, and it's really powerful because we can make our code faster and take up less memory by opting not to spend the time copying function parameters whenever it isn't necessary. So, I went through my code and found all the places where I could do this. For example, here's a function we have called findAll. We can use this to find every occurrence of a string within another string. Now, we aren't modifying the string, we're searching through it all, right? So here's a good place where we can use pass by reference. We don't need a copy of a string just to search through it, right? We can just reference the original string and save time and memory by not copying that string. So here's it now edited. Here we go. This will be faster. But wait, before you do this in your own code, there are several C++ types called integral types. These are bool, char, short, int, and any variation of long. It's my understanding that these integral types are small enough in memory that it's actually faster to copy them than it is to pass them by reference. So here's an explanation of this from Julian Jorge, the man who did a nice code review of this library. Passing integrals as const and arguments is inefficient, as there will be an indirection in the emitted assembly to get its value. If you had passed this argument by value, it would have also fit in a register, and its value would have been immediately available. Number 3, tell your users what version of C++ your library uses. Something that didn't occur to me when I was writing up my library is that everyone is running their own version of the C++ standard with their compiler. If I'm writing a library that lots of people are going to use, I need to tell them what version of the C++ standard it works for, right? In my case, it was C++ 17, so I just put this in the requirements section of my README file. And a bit more on the point of C++ versioning, it's also a good idea to make sure that your code is optimized for your current version of C++. For example, in C++ 17, they introduced the string view object type. This is a lightweight alternative to the standard string object type, which is read-only. Whenever I don't need to modify the strings I'm working with, I can just use the string view object and save some resources. To see what features are available in your version of C++, you can view the link to the documentation I have in the description below. And click on your version number. Here's what C++ 17 looks like. Number 4, add a testing program. Adding a suite of tests to the library is a great way to demonstrate to your users that your library actually works. To do this, I used a really popular C++ testing framework called Google Test. Now, I knew nothing about Google Test before this project, and it's actually not too bad to use. You have to download the Google Test repository from GitHub, and then start writing your own .cpp file to perform unit tests. To start your file, you need to include the Google Test header, and put a main function at the bottom that initializes Google Test and returns run all tests. And in between the header and main function, you write your tests. They look like this. I'm basically calling my functions using these assert statements to expect them to return a certain way. Then when I run the test, I get to see if they all return the way I wanted them to. I can view each test and its result. Pretty cool. I use Cognitive Programmer's tutorial on Google Test as well as some other official documentation to get started with Google Test. You can also find these in the description. So, now that we have our test program, how are our users going to use it, right? Well, they're going to need to compile it so it works with their computer and environment. And Honestly, I struggle with compilers in C++. Working with compilers is kind of a separate skill than writing code, so it makes sense, right? But I've not quite understood what things need to be linked to a project and why. This is the reason why once I get a build command working, I usually just keep copying and pasting it into the terminal over and over again. Very professional, right? However, I discovered something called CMake that happened to be a more professional way of building executable files. Now you might be thinking, Jeff, what does this have to do with your library? Isn't this library just a .h file? I don't have to compile that to use it, you know? And you'd be right, but we are creating an executable file for our test program. Instead of manually finding out what compiler command works for creating the executable file for each environment, CMake figures that out for you. It's very nice. All you have to do is the easier task of creating a cmakelist.txt file for the tests. First, you must install CMake if you haven't already. You can do that at cmake.org. If you're on Linux, you can just run sudo apt-get install cmake, and that's what I did. Once you have that ready, you can write up a CMake list file for your program. So a CMake list file looks something like this. I used a tutorial from Raimu how to figure out how to do this. I have it linked in the description also for you. Now that I have my CMake list file, I can run a CMake command that looks like this. And then CMake generates a make file for me, so I can compile the code. And so now, all the people who download the library can compile and test the code too, all building with CMake. Number 5, add benchmarking. Benchmarking your code means to measure its performance, and it's a great way to show off how fast your code is to your users. To benchmark my library, I used Google Benchmark. So much like Google Test, I had no idea what I was getting into before I started using Google Benchmark, but things ended up turning out just fine. You can download the repository from GitHub and create a .cpp file where you'll be writing your benchmarks. Then you just add the include header, and it's all starting to feel like using Google Test, right? Here's a brief example of what a Google Benchmark.cpp file looks like. So here, at the top, you see the header. Then you got this structure of individual benchmarks right here, as well as registering right below the benchmark. And then you have this weird benchmark main function at the bottom that runs everything. Once you have this all written up, you can use the CMake to build the executable in very much the same way that you built your testing executable. So after using CMake and building your benchmark executable, the result should look like this. Here you can see each benchmark you wrote and the speed of the benchmark. The tutorial I used to get this up and running was created by Ari Seif. I will link it in the description. Number 6, document your code. So I already have some good documentation habits, but it can't hurt to tell you what people are looking for when they start using your library. When you create and release code that other people will be using, here are some things to use as your documentation. First, a README file. An accessible and informative README file tells your users how to start using the library, any requirements the library has, and any other important information that you'd like people using the library to know. For a good starting point, you can look at some other repositories on GitHub and find a good README file that can inspire you to write a similar one. Some of the repositories that inspired me were actually the Google Test and Google Benchmark repositories. And this one JSON for modern C++ repository I found that has some nice badges and images present. The second part of having good documentation is having good comments. It might seem a little bit obvious to say, but the heart of good documentation is good comments. If it is easy for someone to understand your code just by reading it, more people will use your code, and the people that use your code will have a good experience using it. Good comments help with all of this. There's lots of different commenting styles, but the one I use for my library is called the JavaDoc style, where I have a multi-line comment above each function in the library that describes what the function does, what the parameters are, and what the function returns. It's quite a common style, and it falls in line with a lot of conventional style in the world of programming, and that tends to make people happy. So if you have good comments, that's awesome, but not too many people will want to have to dig into your source code to read them. To make all of the good comments accessible to people, you can use a documentation generator program. One such that I used is called Doxygen. If you're new to documentation generators, they won't write a bunch of comments for you. You could probably get ChatGPT to do something like this, but a documentation generator like Doxygen will read your source code files, find your comments, and auto-magically put them into neatly formatted web pages or PDFs, so you can have your own cool manual for your project. To use Doxygen, you can view the install instructions for your operating system on the Doxygen website. Once you have Doxygen installed, you need to create and configure something called a Doxy file. This is the file that will tell Doxygen exactly how to generate documentation from your code, and you can specify lots and lots of different little things to get your desired result and format your final documentation. Once you have your Doxy file configured, then you just run Doxygen with the given Doxy file, and then you should have a whole slew of Doxygen files created. All as web pages here. Pretty cool stuff. Alright, number 7, create a clang-format file. So another issue. When you release your code and someone wants to add on to it, how do you make sure that their style of coding does not clash with your style of coding? This is a more important issue than you might think. And for example, imagine that someone hands you this code and expects you to work with it. Most of you probably don't code like this. So in C++, there's a tool that solves this problem called clang-format. Clang-format is a program that uses a .clang-format file that you create and reformats your code to match the specifications outlined in the .clang-format file. This is great because people who want to contribute to your code can do all the work they want and then run a clang-format tool using your file. And then all of the contributions will then mimic your style. Pretty neat. So I didn't need to get any extra downloads set up for the clang-format from my library. All I needed to do was have a .clang-format in the root directory so that people could use it whenever they needed to format their contributions. I didn't want to have to delve too deep into figuring out how clang-format works, so there was a quick solution for creating a .clang-format file for my code. It's called the clang-format detector program from Clang Power Tools. This is a cool program that reads your source code and creates a .clang-format file automatically based upon the formatting style already present in your source code. So I simply took the output of the .clang-format file from the clang-format detector and placed it in the repository for potential contributors to use. That's all I did. Number 8, choose a license for your code. So licenses are super important. Nobody wants to get sued, so including a license with your code gives people and businesses who are interested in it information on how they can legally use it, as code created by you is under your own copyright. And you should not just add a license for others' sake, but also for yourself. Licenses can include clauses that do not hold you liable for any damages caused by the use of your code. A good place to get started looking about for the kind of license that you might use or assign to your project is choosealicense.com. It translates legalese very well for regular people, and it helped me figure out that my project should be using the MIT license, which basically lets people do whatever they want with the code, provided they make sure to include the license and copyright notice whenever they redistribute the code, and they can't hold me liable for any damages from the use of my code. Now, these changes having been made and feeling a bit more confident with the newer iteration of my library, I resubmitted it to Reddit's C++ subreddit. It got a lot more upvotes and views. I still had a lot of people giving me suggestions and constructive feedback in the comments, but it was not as negative as the first post, so that's good. So what I created is by no means perfect or 100% done, but it's good enough for me to put it on the back burner for now. I hope to return to the project and make improvements eventually, though. For now, though, that is my story of how I made a C++ library and the changes that I made to get it improved. A link to the stevensStringLib and all the resources that made its construction possible are in the description below. Thank you very much for watching, and have a wonderful day.